And we're live.
Yes. My favorite student. She gets everything right. It's amazing. It says, identify the type of reaction. So let's see. For me to figure this out, I notice we have two ingredients. We're adding one ingredient. And we're ending up with two ingredients and one ingredient. So this can't be a double replacement. A double replacement required four things to swap places. The ingredient is an oxygen, so I'm not going to add it's not a combustion ingredient reaction. In fact, I'm pretty sure it looks like this metal is bumping out this metal, so I think this is a single replacement reaction. 1 mark. B. I have two ingredients, two compounds, two elements. Two ingredients, two compounds. I can't say two elements, one element and one polyatomic ion. And it looks like the metals are swapping places. I have the iron with the bromine initially. Now the iron is with the SO4. SO4 is what? Sulfide, sulfate, I can never remember. SO4, sulfate. So we go from iron bromide and zinc sulfate to zinc bromide and iron sulfate. I think this is a double replacement. What about this next one here? Again, I have a single ingredient. Here I have a compound, iron oxide, and it looks like the aluminum is bumping the iron. I think this is a single replacement. D, I have oxygen, so I thought for a minute it might be combustion, but combustion needs oxygen and it needs a hydrocarbon. And a hydrocarbon has to have hydrogen and carbon in it. This is two ingredients combining. We called this synthesis. There should be an N in there. Synthesis. Compare that with E. In E, I have one compound with two ingredients, and I'm breaking it up into the ingredients that it came from. We called this a decomposition. Okay. I didn't put every single reaction on this quiz. The other ones we have are an acid-base neutralization and a combustion reaction. Now we're going to predict the following products. We don't need to balance, we just need to crisscross. Well, looking at this, I have two ingredients, and I'm going to add one ingredient. I'm not going to get three ingredients. I'm not going to get three things in the next compound. I think this aluminum is going to bump this lead. I think I'm going to get Al, Cl, and lead. If you got that, that gets you a half mark, but you also have to do the crisscross properly. So if I look at Al and Cl, the charge on aluminum is 3, the charge on chlorine is 1, so it's going to be Al1, Cl3. So to get the whole mark, you need to have a little 3 subscript next to the Cl. Half mark for aluminum chloride and lead, and then a half mark for aluminum chloride crisscrossed correctly. Is this balanced? No, because I got 4 chlorines on the left, 3 on the right, but I said in the instructions, you don't need to balance. We'll balance further on down the page. B. What kind of a reaction can this be if I give you just one compound? We're going to decompose it. We're going to break it up. It's going to break up into Ca and N. Oh, is nitrogen part of Mr. Hofbrinkel? Technically, it should be N2. So a half mark for the Ca and the N, half mark off if you left off the N2. C. We have aluminum and fluorine, 2 ingredients. I think we're going to be combining these. I think we're going to get AlF, but we have to crisscross. Let's see. Al has a charge of 3, F has a charge of 1. It's going to be AlF3. Half mark for the ALF, AlF, and then a half mark for having a subscript of 3 on the fluorine. What kind of a reaction do you think D is going to be? Double replacement. I think the metals are going to trade places. It's going to be Na is going to combine with NO3, and Ag, which I think is silver, is going to combine with CrO4. Now I got a crisscross. Let's see. Na has a charge of 1. NO3 has a charge of 1. You know what? This one is already crisscrossed properly. Ag has a charge of silver, has a charge of 1, and CrO4, which is chromate, has a charge of 2. You know what? I need 2 of these for one of the CrO4s. So half mark if you have NaNO3 plus AgCrO4. Yep. That's fine. Okay, and technically, even if you wrote NO3Na, it's just traditionally, let's write the metal in front of the non-metal and the metal in front of the non-metal, so all of our answers look the same. Number 3. It says, identify the type of reaction for 1 mark and then balance the equation for 1 mark. Okay, or for a half mark. Half mark for the type, half mark for the balancing. Did I give us a score here? No, we'll make it 1 mark each and 1 mark for the balancing. The type. This is a that gets you 1 mark. Balance it. Let's see. I have 1 CS, 3 of them, so I need to go with 3 there. Oh, but I got 4 phosphoruses. I need to go 4 there. Oh, now I have 12 cesiums. You know what? I don't need 3. Is that right? 12 CSs and a 4. So 1 mark for that, and then 1 mark for the synthesis, and 1 mark for the balancing. So a half mark for the 12, half mark for the 4. Yep. How do I tell if it's, sorry? So you have to memorize. Remember, we had this sheet that we filled out, this type of reaction summary. This thing here where we listed them. You're going to have to memorize the patterns. So a synthesis is when you have 2 separate compounds and they join together to form 1. So remember that pattern, Emily, and take a quick look at this one on the quiz. I had to recognize that the ingredients they'd given me were 2 separate elements and they joined together to become 1. That's a synthesis. Okay? So you're going to have to memorize that little sheet. You can't bring that into the test. Emily, compare that with, can you see here, I have 1 compound, and it looks like they broke it up. That's a decomposition. So for 1 mark, if you said decomposition, that gets you 1. Now I need to balance this equation. I got 2 hydrogens. You know what? I'm going to need 2 oxygens over here, which means I need 4 hydrogens. And to get 4 hydrogens, I just put a 2 there. Is that right? 2, 2, and 1O2? So 1 mark for that, 1 mark for the balancing, and 1 mark for the balancing, 1 mark for the decomposition. Okay. Emily, looking at the third one, what I notice is we have 2 things plus 2 things, and I notice that my metals seem to have swapped partners. My aluminum was with chlorine, now it's with the NO3, and my chlorine was, my NO3 was with copper, now it's with the aluminum. They swapped. This is a double replacement. That gets you 1 mark. Now let's balance. Aluminum's is already balanced. NO3s, I need 3. Oh, no, I don't need 3 of them on this side, Mr. Dewick. I need 3 of them over here. That's going to give me 3 coppers. Pardon me? Are we balanced? Let's see. 1 Al, 1 Al, 3 Cls, 3 Cls, 3 Cus, 3 Cus, 3 NO3s, 3 there it is, balanced. So 1 mark for that, 1 mark for that. So that makes this quiz out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If you can give yourself a little score at the top out of 15, please. And if you need to come lawyer with me, now is the time.
And we're live.
There we go. I feel like, I was going to date myself. I feel like Johnny Carson. Here's Johnny. There, one person in this room got that joke. Ooh, jeez. We've been looking at chemical reactions. Kinsey, in Science 10, we've said there are 6 types. What we want to ask ourselves now is, how can you speed up or slow down a chemical reaction? And some of this you kind of already know. This is somewhat intuitive. So what we're going to learn are 4 factors that affect the rate, and then we're going to try and predict whether these factors would speed up or slow down. So, how quickly or how slowly reactants turn into products is called the rate of reaction. Some chemical reactions happen incredibly fast, explosions. Some chemical reactions happen incredibly slow. I was just reading yesterday, there is an element on the periodic table, and I can't remember the number, but I'll look it up for next unit because we're doing radiation next unit. Up until 2009, we didn't think this element was radioactive, and in 2009 they discovered that it is radioactive, but its half-life is 1,000,000 times longer than the age of the universe. So although it's technically radioactive, it's not. That's about the slowest chemical reaction that still has a reaction occurring that I've been able to track down. There are 4 factors that affect rate. Again, Jessica, I'm lying. In Science 10, there are 4 main factors that affect rate. There are others, but for now. Temperature. Surface area. Concentration. And the presence of a catalyst. These are the 4. Temperature, surface area, concentration, and presence of a catalyst. I have a little video to show you that summarizes this, except the video breaks this up into 5, but it's a great analogy, so it works. Put your pencils down. So, temperature. You already know some of this. Warmer equals faster or slower?
Faster.
Well, I didn't hear you. Huh?
Faster.
Yeah, nice yawn there. Faster. Colder equals slower. That's why we freeze food. The whole goal is to slow down the decay reaction so much that it'll take over a year for it to decay. Remember kinetic molecular theory from grade 8 and 9. Matter is made of particles. The more energy they have, the faster they move, and the more often they collide with other particles. Reactions occur when reactants collide, just like the cartoon that we watched. So if the temperature is increased, the particles move faster. So they collide and react more often. I wrote down here, reading check page 474. We're going to do them all quickly, orally later at the very end of this. Concentration. Right to there? Making sense? So you know enough. You've done enough science now. You could almost anticipate kind of where we're going. Yeah. So concentration, that refers to the amount of a solid dissolved in a liquid. It's the same idea as temperature, in that if the reactants are more concentrated, collisions will happen more often, and so the reaction will happen faster. And have you ever used a pressure cooker? That's what you're doing there, increasing the pressure. Together. Surface area. So surface area is the amount of area that's exposed. So if you have a solid iron block and some steel wool, what has the greatest surface area? Well, the steel wool has all those holes. There's way more surface that's exposed. That's why steel wool would rust way faster than a solid iron block. The solid iron block, the outside of the block will rust, but the inside, oxygen can't get to. It'll stay pristine, where the surface area of the steel wool is such that it'll rust very, very fast. So the steel wool does. This allows, try that again, Mr. Duick, more collisions to occur. And therefore, the reaction happens faster. Nearly done. Told you it was a short lesson today. The last thing, the matchmaker. Presence of a catalyst. Catalysts speed up the rate of a reaction, but they do so without being used up themselves. I didn't leave quite enough room to write that in there, I think. Without being used up themselves. So they stay unchanged, but they speed up the rate of a chemical reaction. They're useful in situations where it isn't practical to increase temperature or concentration or surface area, where it isn't practical to increase the other three. All of you have lots of catalysts in you because your body is running millions and millions of chemical reactions, but really we have a limited temperature range in which we can run them. In fact, you're very sensitive and susceptible to hypothermia, get too cold, the chemical reactions can't work anymore, you'll die. And fever, get too hot, chemical reactions don't work anymore, you'll die. A biological catalyst is referred to as an, you guys have seen this word before, does anybody know it? It means the letter E. Ooh, new word. Enzyme. Enzyme. How do they work? Well, what they do is on a molecular level, they will help. You may recall the video said you have to be lined up correctly to bump into somebody else to knock the books from their hand before true love can occur. They hold the reactants in a proper alignment. In a proper alignment for a reaction to occur. In other words, they make the collision more likely to occur. Can you open your text?